All right, here's 3.1, day 1. We're solving inequalities today. First slide here, what to pay attention to is when we're graphing solutions to inequalities, pay close attention to if we have a less than sign, greater than, strictly less than, or strictly greater than. Okay, when we graph solutions on a number line, this dictates if we mark the boundary to the solutions with an open circle or a closed circle. Okay, best way to take a look at this is with some examples. For example, if we want to graph the solutions, x is greater than or equal to negative 3. I'm going to make my number line. In fact, I'll make all my number lines here. Whoops, this one doesn't need to be that big. All right. I'm going to start by putting, there's nothing to solve here, first of all. I'm just practicing how I graph a solution to an inequality. I try to make sure your numbers are nice and evenly spaced. Notice I'm going up to 4. You're drawing these out by hand. You just want to do the best you can to make them as neat as possible. You know, anything that's handwritten is going to have a little margin for error. That it's not going to be perfect. Okay. This inequality is greater than or equal to negative 3. So that means at negative 3, I am going to mark that with a closed circle because I'm saying, as far as my solutions go, that point, negative 3, is a solution. Okay, now it's a greater than sign, so I'm looking at everything else being shaded that's to the right. Okay? Do the same thing here, use 0 as our reference point. I'll be good going up to 4. Now I'll just go down to negative 2. Okay? Now here we have an interval because we have a starting point and we have an ending point. Okay? The set of solutions starts at negative 1 and it goes up to 3, and everything in between would be solutions. Okay, now this is very significant right here. This says if x is less than or equal to negative 3. Now compare that with this, where it's just strictly greater than. This circle at 3 is going to get shaded, which again signifies the fact that 3 is a solution. Negative 1 is not, because the inequality does not say to include negative 1, so that circle remains open and unshaded. Oh, notice right here we have a little bit of solving to do. Those will cancel right there. My solutions will be y, that's my variable here, is actually greater than or equal to negative 3. Notice here I divided by negative 2, which takes the sign of that inequality and it changes directions. So now I'm going over to my number line here. To graph my solutions, I want greater than or equal to negative 3. This is another one. I'll use 0 as my reference point. Go up to 3. I'll go down to negative 3. That forms the boundary for my solutions. Notice it's greater than or equal to, so the greater than says I'll take all these numbers that are bigger than negative 3. Those are also solutions to this. And I'm going to shade in the circle at negative 3 because the number negative 3 itself is also a solution. All right, here's one more that we will graph. I'm going to get my number line going here. On this one, you see, we've got a little bit of work to do to get the solutions because we got some solving to do. All right, this one isn't in the form to just graph our solutions right away. We got to get it solved for x. We'll use inverse operations in just the same way as we would if it was an equation. I subtract x, and that leads me to 2x minus 4 greater than or equal to 10. Then I will add 4 to both sides. Those cancel. I get 2x is greater than or equal to 14. I then divide by 2. 2's cancel. X is greater than or equal to 7. Okay, greater than or equal to 7. Notice at no point in time did that inequality switch directions, largely due to the fact that I did not multiply and I did not divide by a negative number, so the direction of the sign did not change. Okay. So now I need to graph x is greater than or equal to 7. I'm actually going to put 0 over here because I need more room for positive numbers. As I got -1, -2, and -3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we go. All right, I want to graph that my solutions are x greater than or equal to 7. So here's 7. That's my boundary point. It's a greater than. I want everything to the right. And it's greater than or equal to. So I will go ahead and shade in 7, as that is included as a solution. Okay? Again, the big thing here was graphing the solutions on a number line. As far as solving goes, remember they're just like equations. The only difference would be if you multiply or divide by a negative number, like I did in one of the examples, the inequality needs to change direction. Okay? We'll call it quits there. If there are any examples that gave you any trouble, please let's talk about those more.